This is our second conversation in Chapter 7, and what we're going to talk about now is work. And work is a term like a lot of the other physics words that in physics it has a very specific definition. So be sure to review your vocabulary, your Quizlet, and remember in the world of physics what work means. We've talked about energy. After we talk about work, we're going to look at power and kinetic potential and kinetic energy, conservation of energy, ending up with machines. When we talk about work, we're talking about a very specific relationship. This is a derived relationship, and where in impulse we looked at force over time. And now for work, we're looking at force times the distance. This gets to be really important in our simple machines. We're going to look at the application of the force and the things that move as a result of the force. Um, so when we're talking about forces with work, we're actually talking about work done on one thing by something else, which is how it relates to momentum. Here's an example, and you've seen this one before, that when we push on the wall, we looked at this example before for an equal and opposite reaction, that the wall pushes it back for us. But when we're talking about work, and at this situation, is there any work being done? Is there work being done on the wall? Is there any work being done? Is there no work being done? That's kind of the question. And because nothing has moved, um, there has been no work on the wall. Now, theoretically, there's maybe been some sort of work on your muscles, something within your body and the muscle tissues going on back and forth. That's a little bit beyond what we're going to talk about in physics. In physics, we're talking about our push and what happened to the wall. Since nothing moved, there's been no work. No work. Let's look at a more practical application. So these are situations where there is some work going on, and the consideration, if we need to lift something only up to one level as compared to getting something lifted up two levels. Hey, work is pretty easy when we have to lift something twice as far. We say that there's twice as much work getting done. Either because the mass has doubled or the distance has doubled. And that's a really practical application for what work looks like. We're either moving more stuff or we're moving the same stuff further. And again, if the weightlifter is moving the weights from the floor to the height, then there has been work done. If the weightlifter is only holding the weights stationary and not causing any movement, then there is no weight. When we talk about weight, the unit of measure is a Newton meter, or more commonly called a joule. And it's a joule named after a scientist. Um, so it's force, work is equal to force, the newtons, times distance, which is the meters. I think you're going to find work to be a pretty straightforward factor to work with. Here's a question. When I lift a twice as heavy barbell the same distance, what does that do to my work? Twice as much, half as much, the same, or does it depend on the speed? Well, I'll give you a hint. Work does not take into account anything related to time. So the speed of it doesn't make a difference. Speed makes a difference to momentum, but not to work. What you need to look at here is you're heavier, same distance, heavier, and because of that, we talk about the work being done as being twice as much because the distance is doubled. Um, so how about if I'm pushing a cart and I only have so much force I can push it with? What about if I'm pushing it, if I push the distance double? Is my work the same? Is it more? Is it less? Again, work is a pretty common sense factor. And in fact, in this case, if I'm pushing it twice the distance, my work is doubled.